Hi guys, welcome back. Let's see how your petition go. So based on this table right here, let's see what kind of pattern you see. You know, it's go 2, 4, 8, 16. So what do you think? What's the pattern here? So if you notice that 2, it doubles to 4, 4 doubles to 8, 8 doubles to 16. So the rule seems to be that you just double the previous number. So that seems to be the rule. So based on that rule, I think that this should be 32. Yeah? So I think it should be 32 non-overlapping region. So that means on example 4, you want to do an evidence show that. So I went ahead and draw that for you. Okay, so based on the strategy, you pick a point and you make sure you draw each connection line right here. Then you pick another point here, and then you continue connecting all the lines. Stick with one point you start, then you move away and do all that, and then just count it. Okay, so let's see. Yeah, so this is true. So here my evidence. There is 32 region. Just in case you didn't realize it, this right here is the region. Just want to make sure you know. Okay? So if you came down to 31, that means you're missing this spot here. Again, you want to draw it and count it, and if you think you have more than 32 or less than 32, let me know, and I can help you out and see if you're missing any spot. Alright, so to the next page. So one more definition. We're now talking about deductive reason. Now deductive reason is based on rule and facts. Okay? So the rule of a logical reason. Okay? So if I ever have an argument, it's basically a series of reason and facts that support a given statement. So in geometry, it's not about disagreement. It's about I have a bunch of reasons proving that this is the true statement. So again, you have a bunch of series reasons and that support a given statement. Okay? Now, if anybody ever talk about proof, it's basically an argument that uses definition, axiom, postulate to show that the statement is true. Okay? And finally, if you ever come to the word theorem, it's a statement and conjecture that has been proven to be true. So there's no way to prove it false. It's true beyond doubt, and there's already been evidence showing that it's true, and nobody can figure out how to disprove it. So it's been true for now. Okay? So an example of it would be like an even integer. If you have a number, an integer that have no remainder of 0, when it divided by 2, it's going to be even. So if you're thinking, hey, 4, is 4 an even number or an odd number? Well, let's divide it by 2 and see what you get. I get 2, no remainder. So that means that this 4 is an even number. If I want to know if 4 is an even number or not, I go ahead and divide this by 2, and I found I'm going to get 7, no remainder. Okay? So that means I know that 14 is an even number. And just like right here, 4 is an even number. Okay? Now here's an odd integer. Here's the theorem for it. Let's say an integer have a remainder of 1 when it's divided by 2. So basically, if you have a decimal, it's definitely an odd one. So for example, when 3 divided by 2 here, you're going to get 1 plus a remainder of 1. So that means 3 is an odd number. But to make it really simple, all you have to do is look at it, divide by 2. If you get something decimal, then the chance of that's an odd number. Okay, so that theorem, there's no way to disprove it. It's already been proven enough time to show that, hey, it's odd when you get a remainder of 1. Alright, so these are some more complex things. This is why geometry involves a lot of thinking. Okay, so here they say calculate the sum of some pair of even integers. So sum means you add, okay, the total. Show example that used to make conjecture about the sum of two even integers. So they want you to use two even numbers, add them up, and tell me what's happening. So 2 is even, plus 4 is even. When you add them up, you get 6. Okay. You have 8 plus 12, that gives you 20. Okay. 6 plus 10 gives you 16. Well, I mean, you have two even numbers, it will give you a even number. That seems to be the rule here. Might be a theorem here. So, if I want to write it out, I would say that the sum of two even numbers is always an even number. So no matter what two even numbers you add, you get an even number. If you find an example that shows that is wrong, please let the teacher know. Otherwise, I think it's a pretty safe bet that every two even numbers add up to an even number. Well, let's do another example. Take a look at example 6. So Todd knows that 3, 5, 7, 11, and 13 are prime numbers. So a prime number is a number that cannot be divided except by itself, by 1. It cannot be broken into any other number. The only way you can break it down is divide by the same number. So based on this evidence, he concludes that all prime numbers are odd. It seems to be it. 3, 5, 7, 11, 13. Is this example of inductive or deductive? Well, you're getting a number here. All you're seeing is pattern. You see that all the prime numbers are odd, so therefore every prime number should be odd. So this is an example of inductive reason. Why do you think that is? Well, again, if you look at the definition, inductive reason, because it's based on the observation of pattern. Based on what we see, that we saw all the prime numbers look like odd, so therefore we think the prime number is odd. In reality, it's been proven that not all the prime numbers are odd. This is actually not true. Okay? Because 2 is a prime number and this is even number. You know? So just like I mentioned before, inductive reason is just a prediction. It may or may not be true. Inductive reason is just based on observation of what you see, and sometimes what you see is not always true. Okay? Deductive reason, on the other hand, you use a bunch of reason, rule, and facts to show that it is true. Alright, so now what I want you to do is on the last page, go ahead and do a closer question, and then just compare and contrast the theorem and conjecture. Yeah? So what do you think the difference between it? Just write it out and let the teacher take a look.